So welcome guys to yet another machine learning tutorial video. In this video I will be explaining about multiple linear regression and along with its code. So without any delay, let's get started. Welcome to part 4 of machine learning bootcamp. In this video we will discuss multiple linear regression and one hot encoding, that is converting characters into binary data, and the third thing is handling missing data and predicting values of multiple linear regression. So let's go without any ado, let's get started. Right, multiple linear equation. What is multiple linear equation? Yeah, an equation which is having more than one independent variable and only one dependent variable depending on this multiple independent variables, right? The equation of multiple linear regression is given as like this: y is equals to ax1 plus bx2 plus cx3 plus d. Here a, b, c are coefficients of x1, x2, x3, and as you know, x1, x2, x3 are independent variables and y is the dependent variable. Here d is a constant, right? Here this is what all about multiple linear equation. So let us start coding. So click on new notebook. So the first thing is, let me remove this thing. Yeah, multiple linear regression. Multi-linear regression. The first thing we have to do in every regression code cell is add an import class. Importing libraries, and then start from here. As you know, first thing is import pandas as pd, in the short form of pd. Import matplotlib.py plot as plt. Import numpy as n, as short form, and as short form of np. So let us run this code. The second part is fetching the data set. Fetching the data set, and let us do it from pandas, right? Let us create a variable data set is equals to pd dot read a csv file. So let us write it here. Yeah, okay, copy this path of this data set and paste it over here. Control V. So x is the independent variable, x is data set dot iLoc. I is a variable and locate I variable from, it should be of all the rows. The space before the column is indicates 0, and the space after the column indicates the last index. So it's the range of the column should be from the 0 index till the last index. And let us see. we want 1 0 1 2 3 4. So we want this 4 independent variables, and we have to not include profit here. So for that, the space before colon indicates the 0th index, and after the colon it indicates the last index. So we want it from -1, so it is like 0 -1 -2 -3. From if you read it from opposite side, it's like -1 -2 and -3, right? So we don't want to include this, so we are writing it like this, and we want its values y is equals to dataset dot ilog, right? We want all the rows, from 0th index to the last index, and we want only the last column. For that, we have to type -1 dot values, right? Let us run it. Yeah, good. Let us print out the value of our independent variables and dependent variable. This is what our independent variable values are, right? These one, and these are the dependent variable values. Yeah, good. Now we have to implement one-hot encoding in this state variable, because in state variable the data present is categorical, right? Like in characters or in the string, right? And whereas in the other independent variables, all the data is present in a numerical value. So we have to, for better understanding of computer, we have to convert this into binary numbers, right? So for this, New York will have like binary number 100, and California 010, Florida like 001, like this, and there are like only 3 states, so we need 3 bits of binary data. So one hot encoding categorical data, yeah, code. So for one hot encoding, we have to import 2 libraries from sklearn.compose. From this, we have to import a library called as column transformer. To change this column value, we need this library called as column transformer. From sklearn.preprocessing, from this library we need to import a sub library that is one hot. Is it the right spelling? Yeah, correct, right spelling. So from this library we have to import this sub library. So one hot encoder is present in this thing, this sklearn.preprocessing. So now let us create an object of column transfer class, CTR, C column transfer, yeah, good name. So column transformer, yeah, good. And it takes parameter, as one of the parameter is transformers, right? Transformers is equals to, and this parameter transformers contains list of tuple. It is a list of tuple, which the first value is, there are basically 3 values. The first value is what type of changes are you doing? We are doing like an encoder to this column, to the columns. And what type of encoder we are doing? One hot encoder from here. As you can see, one hot encoder. The same thing is going to be here. One hot encoder. So encoder, and this is the type of encoder. As it's an object, we are going to give it parenthesis. And the last is, on what column do you want these changes to be done? So here if you see 0 1 2 3, so if you see here 0 1 2 3, so in the third column we want to do encoding. So write it here in the third column. Yeah, good. And the second parameter of column transfer is reminder. So it tells what to do with other columns, what changes you want to do. So we don't want to disturb other columns, so pass through it. We don't want to disturb other columns, right? Good. Let us run it. Why are we getting this error? So column transfer got an unexpected keyword argument reminder. Okay, sorry guys, reminder, the spelling, I just went wrong with the spelling. Reminder. Yeah, successfully created an object here. Cool. So we want to make changes to the independent variable of x using this object. So we want to fit it and transform the values of x. So the new x is going to be this. The new x is going to be the fitted and transformed value of x. So this is the new x. Let us run it. And let us also print the value. Yeah, got it. But his values are corresponding to our state. New York is corresponding to 001, right? And California is corresponding to 100, and Florida is corresponding to 010. But what if any values here? But there is a problem in our data set, is that it contains some missing values. We have to handle these missing values. For that, let us type handling missing values. Handling missing values. So how do we handle? One of the method is just deleting the rows, so that we don't need rows, and we can handle it like that. But it's not a good way of handling data, because if it has a big data, then removing all the rows and column is a tedious task. So now let us handle our data without deleting our rows. Handling data missing data. Let's code it from sklearn. Impute is a library that contains import simple imputer. By using this simple imputer, we can handle this missing data. What we would do is, so this missing data, we can add all the values of this column and make it a mean, and the mean of all these values is going to be the value of this. Just for approximation, see, if you see these values are kind of related, so we have to find the approximate value related to this. So this is the way we handle data. So this value is going to be the mean of all these values. So the object of simple impute SI simple imputer, right? So it takes two parameters, missing value, one is the parameter missing values. Missing values is np.nan, that means null, and the second parameter is strategy, yeah, and the strategy is going to be mean. We have, if we get any missing values, if we have any missing values like np.nan, that means null. If we are having this 0 values, make it mean of all these values. That's it. So text. Now let us split our values. Now we have dealt with Onehotencoding and handling of missing data. Now we have to split the data set into training and test set code. So from sklearn.model selection, we have done this in the previous tutorial also. Model selection, import train test split, and the return type of train test split is 4 variables. One is x train, x test, y train, y test, train test split, we want to split x and y, and the test size should be 20% of the total size, and the random state should be 0 because we don't want to change our values again and again. Now let us train it. Training our training set data from sklearn dot linear model, as we are doing multiple linear regression, linear model, import linear import linear regression, and let us create an object for this, regressor linear regression, and we have to train this regression model on, we have fit means training it on xtrain. We want to train it on in the training set, and y train. good. Showing exchange not defined. Yeah, sorry, I did not run it. Y should be small. Yeah. So we got the object here. So now predicting values of training, predicting values on test set. Code it. So in the last tutorial, as we have seen how to predict values, let us create a variable ypred, right? And regressor dot predicting values of x test. So y here ypred is the generated value from the predicted value of x test that has been generated on this regression model, this regression object. From here we have predicting it, right? Let us print the values of ypred. Ypred, let's see the output. So this is the output of ypred, and what is the original output? Let us do a comparison between comparing original value to that of trained value. So code. So for that, what we will do is we will stack the original value and predicted value side by side. For comparing our original value and our predicted value, we need numpy to concatenate our original value and predicted value side by side, so that we can compare these two values. Numpy dot concatenate, that's right. And we need, as you can see, concatenate syntax, it takes two parentheses, so we need to take two parentheses, yeah, good. Y test value and y predicted value. Let us print this value. Print yeah. So this is the original value and this is our predicted value from this regression line. This is the second and this is the second predicted values. So why not? We do it? Why not we just stick it side by side without being this clumsy, making this clumsy? So for better comparison, what we can do is we can make predict y test value one side and y predicted value one side. So for that we have to reshape it. So that we reshape it into the row size should be that of the column size here. So the row size should be from here to here, right? Rows length of the first parameter takes the size of rows, that is y test, and 1 should be the size of our column. There should be only one column for y test, and we are also going to reshape ypred same as here. Copy, paste. and here I'm using -1 here because to separate these both uh, arrays. See, we have successfully separated this value and this, so now good comparison, we can compare it in a better way. Now let us see the accuracy of our model. We test our accuracy using r-square accuracy. So as we have seen from the documentation in the last video, uh, we import r-square like this from sklearn dot metrics import r-square score. Now let us print the accuracy of our model. Print r-square score one parameter is test and accuracy of these both. How close are they? Yeah. Yeah, it's like 93.4% accurate. Yeah, we got a good regression model here. Nice. So that's it for this multiple linear regression. If you like this video, please like, share and subscribe, because it took a lot of effort from my side to make this video. Keep enjoying and keep learning machine learning. Until for then, signing off, Salman in Tech.